Hello, I'm Sina Moallemi, and I'm the product manager for RS3. In this video, we want to see how to use hybrid mesh to accelerate the computation while keeping the accuracy of the results. One of the most important factors to do an accurate finite element analysis is using a correct discretization for the model. This means that the type and the density of the mesh should be proper enough to capture the correct behavior of the model. So let's take a look at one example in RS3 to see how we can use hybrid mesh to get an accurate result quickly. Here you can see the geometry of an open pit, and we are interested to find the factor of safety for this model using SSR analysis. To discretize the model, we go to mesh setting, and as you can see, we have three different options. One is 4-noded, 10-noded, and the last one is hybrid, which is a combination of 4 and 10-noded tetrahedral elements. To do a comparison between these options, first I assign a 4-noded elements, and then I did the SSR analysis. So let's open the final computed results and check it out. Here we have around 343,000 elements. I go to the Result tab, and I activate the results on the external boundary, switch the data type to total displacement. The critical SRF is 1.5. So I switch the value to the critical SRF. The failure is happening due to the sliding of the slope along one of the faults in the model. For the second case, I use the same number of elements. As you can see, we still have 343,000 elements. But this time I use 10-noded elements, which are higher order and can capture the deformation and stresses more accurately. So I switch the data type again to the total displacement. The critical SRF is now dropped to 1.3 from 1.5 that we got from the previous case. However, the mode of the failure is very similar to the previous case. This result is more accurate because we are using higher order elements, but since we are introducing more degrees of freedom, the simulation is almost 10 times slower than the 4-noded case. So now let's go back to the original model. With the third option, we can use a combination of 4-noded and 10-noded in the same model. We can assign the 10-noded elements at the region which is more likely to fail. In this case, it's the area closer to the fault, and use 4-noded elements for the rest of the model. Let's see how it works in action. To assign the higher order region, we go to the mesh, define higher order region. And now I can locate the box at the area that I would like to have higher order elements. Now I go back to the mesh setting, and this time I use the third option. As you can see, the higher order region is detected, and then I can click mesh to get the final discretization for the model. I repeated the same analysis for this case, so let's go and check the results. Here we could capture the same critical SRF when we were using 10-noded elements. And let's check the mode of the failure as well. The critical SRF is 1.3, similar to the case when we were using 10-noded elements. However, since we are using significantly less degrees of freedom in comparison with the 10-noded elements, the simulation was done almost 5 times faster than 10-noded case. You can see a summary of the time and the results between these mesh types. Thanks for watching this video. If you have any question about hybrid mesh, or you would like to see any specific feature within RS3, leave your comment below.